Okay, so we're recording. I'd like to start with just a quick announcement about test 2 and some work I've done to get stuff ready for that. It's still a ways off, but the sooner you can start sort of thinking about it and preparing, the better. So test 2, we're just going to make, so as a reminder, we're not going to do 3 tests anymore. We're just going to do 2 tests and then the final. And so I'm just going to do 1 test on Trig. And so I know we had a little bit of stuff sort of hanging out there before Trig that we didn't do a test on, but I'm going to sort of ignore that for right now and just have our next test on just trigonometry. And I'm looking at the schedule and when things are due, and I had mentioned the week of the 20th. Well, the 20th is Patriots Day, so technically we're not supposed to do class that day. And I'm not really able to do it Wednesday because I'm doing a test in a different class, or Tuesday, I mean. I guess that is Wednesday. I forgot the day. Anyway, I was sort of thinking Thursday the 23rd. I'm just sort of realizing if Tuesday the 21st is better, we could do it Tuesday the 21st. But then, actually, I remember why I wanted to do Thursday, because the homework for this is due the Wednesday before that will be on this test. And I was sort of thinking Tuesday we could do some review and talk about that homework, and then we'd have the test on Thursday. So anyway, I think this is the best day looking at the schedule, Thursday the 23rd. I'd like to do it like sort of in class, so to speak, in that I mentioned this before, but the way it'll work is I will we'll all meet via chat, kind of like this, except you'll turn your cameras on and you'll set it up so that I can sort of see you taking the test. And then as you work on it, I'll watch you taking the test. You can, type in the chat questions, or we could text back and forth or something if you have questions. And then when you're finished, you would scan the test via taking a picture, or a scanner if you have it, but taking a picture is fine. And then you would submit it back to me, and then you'd log off the video chat. And so that's sort of the process. I'd like to do it on Thursday the 23rd. I've already posted practice problems and topics and stuff like that. But we're kind of right in the middle of the trig. And so, you're welcome to start looking at those practice problems, but we've got a couple weeks here left of trig, obviously, before we do that test. So that's what I'm thinking. Are there thoughts about the test or anything I just said there that you want to comment on, or if that's a bad day for some reason I'm not thinking, if you would let me know. Okay, well, if that sounds all right with you, I would like to move forward with that, and we'll look more into that as we keep going. So there's 3 homeworks due on Wednesday evening, and I mentioned last time, they're kind of, in my opinion, at least 2 of them are fairly challenging sections. So there's trig graphs, which can be tricky, trig inverses, sometimes people have a hard time with, and then arc length and area of a sector aren't too bad, but I got a question about one of those homework problems. And so I'm happy to look at those homeworks if people have questions about them, or the specific notes for today were the trig of right triangles. It was the SOHCAHTOA notes that we were specifically supposed to talk about. And so can we start maybe by seeing if there are any questions about the notes? If there are specific questions about right triangle notes, so SOHCAHTOA stuff on this page, or specific questions about other parts of the notes, I'm happy to look at those first, and then if you have homework questions, we can look at a couple homework questions.
Can we go over the second part of that page?
Anything I can clarify with respect to those?
Professor?
Maybe while people are sort of thinking about those notes, I've been kind of keeping track of, who's working on the homework, how many people are watching the videos and things like that. I can't see who's clicking on YouTube, but I can see like how many views there are and things like that. And I'm just slightly concerned about people's approach to class and whether or not you're sort of doing what you need to do. But, it's completely up to you. And I know this new format is sort of thrust on all of us. But I really want to encourage you to avoid sort of like waiting till Wednesday nights to try to learn 3 sections at once while you do the homework. I really think if you try that, especially with these trig sections, It's going to be very, not just difficult, it's going to be prohibitively hard in terms of learning the material. That's obviously not the correct way to approach a course. You should be breaking it up and doing it sort of over the course of the week like you normally do. And I think you might have a really hard time if you don't do that. And again, looking at just the way people are working on the homework or not working on the homework, it seems like maybe you're just leaving it all to the last Wednesday. All right, there's no, if you don't have questions about the notes, it makes me wonder if you're looking at the notes. Anyway, I think you're going to run into a wall if you sort of avoid doing this, is sort of what I'm trying to say here. So anyway, I don't mean to lecture you too much on that, but it's more of like a pep talk. I'm hoping you're taking these online classes seriously and really trying to learn here. Anyway, can I answer some questions about the notes? Does anyone have anything about these notes to show? I mean, you could even say, like, can you run through SOHCAHTOA and remind me about what that means? That would be fine. Anything about the notes you want me to say? Okay. Fairly confident there aren't questions because you just haven't looked at the notes yet, which is just really concerning. But anyway, I'm doing what I can, the best I can. I hope you're doing the best you can too. I did have one homework question someone sent me, and I'm still happy to look at more. Like if you're looking at the homework right now and you wanted to shoot a question over, you're welcome to. Someone at least sent me this one ahead of time about it's from the arc length and area of a sector chapter.
Can you hear us?
In here. I get this one asked a lot, and I know it's a little bit tricky because it uses minutes. And so let's just see what it says here. It says the distance along an arc on the surface of the Earth that subtends a central angle of 5 minutes.
Professor?
What
Can you hear us?
Radius, excuse me, the radius of the Earth is this, and it wants the distance of the arc. Excuse me. So it says find the distance of the arc. So let's draw a picture of what this is. So this is the Earth. That's my horrible picture of the Earth. Wow, I wish I could draw a circle. So that's the Earth. Let me make this a little less bright. So there's the Earth. It's telling us that we have a radius of 3,960. And so the radius is 3960. And then it's telling us the central angle is 5 minutes. And so that's kind of the tricky part about this one. So 5 minutes. And it wants to know the distance along the surface of the Earth, right? So it wants this distance right here. It wants the surface of the Earth distance. And so that's exactly what arc length email of a sector is. It looks like someone maybe was asking a question here. Okay, looks like people were trying to talk. Can someone try to talk again?
Professor?
All right, I can hear you now. I'm sorry about that.
Okay.
So I guess you guys are asking questions. I'm sorry, I was just sort of sitting here waiting and you guys are all talking. Can he hear us? I just emailed him. He definitely can't hear us. I don't think he can hear us. Sorry! All right, let me finish this problem and then I'll get back to those questions. I'm really sorry, guys. I was getting feedback on my computer, so I had muted my output volume, and then I forgot to unmute it. Okay, so anyway, let's finish this problem before we look at that. Let me pull the notes out that correspond to this particular problem. Looking for the arc length area of a sector. Just had it a second ago, and then I put it away. So we're looking for this formula, right? The length of the circular arc. And so this tells us that the specific length of the arc, which is S, is going to be given by the radius, r, times the angle, theta. But the key thing is you need to have theta in radians. And so the first thing is, like, we're being given theta in minutes, and so we need to change minutes into degrees because we're told how to do that, and then we can change degrees into radians and use that formula. And so we want to use the formula S equals r times theta. You need theta in radians. And we're being told that 1 minute is 1 over 60 degrees. And so let's change that to minutes first. So we've got 5 minutes. And so let's change 5 minutes times 1. I'm sorry. So 5 minutes is 5 over 60 degrees. So 5 minutes equals 5/60 degrees. And so that's our theta value in degrees, whatever 5 over 60 is, which is what, 1 over 12. But then we want that in radians anyway. So we need to take 5 over 60 and change it into radians. And so we do 5 over 60. The way we change that into radians, so that's degrees, we want to multiply by pi radians over 180 degrees. And remember, the way you remember that is because we want the answer to have a pi in it because it's radians, and then the degrees are going to cancel out that way. And so our theta value is 5 pi over 60, which is 5 goes into 60 12 times, right? Yeah, so that would be 1 over 12 pi. That's our theta. And it's in radians because it's got a pi. And so we just do r theta with that being theta and that being r, right? And so S equals r times theta, which is 3960 times 1 over 12 pi. And you're welcome to get a decimal for this. That's miles. Or you can just enter it right like that. Like we talked about that yesterday. Instead of trying to plug that into a calculator and getting some really long decimal that you're going to have to round, try just entering it right like that, and it'll go directly into WebWork, just like that. Are there thoughts about that particular one?
If 1 minute equals 60 degrees, how can you put 5 over 60 degrees? That's where I'm confused.
So it's like if 1 minute is this, multiply both of these sides of this equation by 5. And so it'd be 5 times 1 equals 5 times 1 over 60, right? And so you'll get 5 minutes, and then this goes into the numerator when you do that multiplication. So it's saying every minute you have, that's 1 over 60. And so if you have 5 of them, that's going to be 5 of them, right? So 5 over 160. Or excuse me, 5 over 60. What is minutes? Is that something you use in the Army? Is someone in the Army here that can answer that? Do you describe distances in minutes? Like, I know sometimes in movies and things they talk about like clicks, which I've always been a little confused about. I feel like minutes is like an Army measurement anyway. I'm not really positive about that. It's a nautical distance, I guess. So a minute is a nautical mile, it says. Yeah, so Gabe says minutes are on a compass. So, okay, cool. So just a different way to measure distance. But use degrees in the Army. Cool. Good to know. Thank you for that. Thoughts about this? Other clarification questions about this particular problem? I apologize again for not being able to hear you here. I saw Christina was asking about second part of 59. Caroline was asking page 60. So we can do that for sure. And then maybe some other people were talking that I couldn't hear as well. So I can run through the notes quick, 59 and 60. Did someone else say something else that I missed? Maybe let me just do that, and then you can let me know if there's more you want to hear. So I had wrote not on test 2 last semester. This is on test 2. Sorry about that. These are my notes from last semester, technically. So this is on test 2 because, again, test 2 is going to be all of Trig. And so this is part of Trig. And the idea is like this tells us how to relate sides on a right triangle. And you can remember these relationships with the SOHCAHTOA form. SOHCAHTOA, what do you call that? Mnemonic device. And so the SO stands for sine is opposite over hypotenuse. The CA stands for the cosine equals adjacent over hypotenuse. And the TOA means tangent is opposite over adjacent. And so the thing to remember, which I harp on a lot in the videos and which I'll try to harp on here too, is, you know, the hypotenuse, here's a picture. The hypotenuse is always going to be the longest side, but opposite and adjacent change depending on what angle you're talking about. And so if theta is in this corner, opposite is the one across from it. And so that's what makes this one opposite. And then adjacent is the one that touches it. But if you were talking about this angle up here, like if theta was up in the upper corner here that's blank currently, then all of a sudden this would be the opposite side and that would be adjacent. And so depending on where you are, like that's what I tried to write right here. Depending on where you are, will change what opposite and adjacent are. And so there's lots of different problems you can do. Sort of wondering what the first question was, the second part on page 59. So I think maybe we're talking about these ones down here. The thing I was trying to get across in this particular section, and now that I'm thinking about it, the values in the video might be different than the values that I wrote here. I potentially may have changed that. But what I've written right here is just sort of noting how if you're on alpha or beta, and alpha and beta are different angles here, it changes what opposite and adjacent are. Values are the same. Okay, Cameron says values are the same. Good. So, so for example, if we're talking about sine of alpha, well, sine is opposite over hypotenuse. That's the SO part of SOHCAHTOA. And if I'm here on alpha, then opposite alpha is going to be the 4 because it's what's across from it, right? But if I'm on beta and I want to do across from this one, it would be over here. And so it really just depends on like which angle you're on, sort of dictates what opposite and adjacent are. But hypotenuse is always the same, right? So in both these formulas, like hypotenuse is the same on both of them, and you get the same number for the same thing. Yeah, so that's right. So Caroline's pointing out that I sometimes just do this bottom section a little differently when I'm doing the course. And so I may have added a couple differently on this one compared to the video. But everything in the video and on here is true. It just might look different. So it was Christina specifically who asked, I think, questions about the bottom of this one. I don't know if that clarified it for you or if there were specific values you wanted me to talk about.
Yeah, it was that part. Thank you.
Okay, great. Other thoughts about this page before I run through page 60? I saw that there is a question about page 60. Can you go over the second half of page 60? I can definitely do that. So the second half of page 60 and then 61 are like the real applications of this stuff. Like 59 and the first half of page 60 is trying to give you the idea behind how this stuff works. But then this is like really using it on a problem, right? And then like this is an actual application where you're trying to find the height of a tree. And so the idea behind these problems is that you're given usually a triangle, but you're usually only given one of the angles. And so in this particular one, we ended up like solving for the third one. But the idea here is like, oh, I'm sorry, what I meant was you're usually only given one of the sides. And so you can't use Pythagorean theorem to like find all the sides of this triangle, because in order to use Pythagorean theorem, you need 2 of the sides. And so if you only have one of the sides, that's where you really need to use this trig stuff. And so maybe let me redo this one on a separate piece of paper. It's kind of hard to like run through this when it's already written down. So let me just sort of do this one from scratch a little bit and show you what I mean. So I'm going to redraw that triangle so it looks like this. I'm going to reorient it a little bit. And when I do that, it's got side x here. This was side 4, and we know this is a hypotenuse. And the question is really like the key question here would be find side x and side h. Right, so we want to find the missing sides, but we only have one of them, and we're usually given an angle. That's right, we're given this angle is 30. And so we can't do a squared plus b squared equals c squared because there's only one thing we know. And so we're missing 2 things, right? And so the way that this works is we can use SOHCAHTOA to relate the angle with one of the sides and then figure out the other one. And so I'm going to start by maybe finding x. I'll find x first. And so if I want to use this angle we're given, so let's use the 30-degree angle because we're given that. And let's use the side that's labeled 4, because that's also something we know. Well, if we're talking about this angle and we know this side, this angle is across from this side. Right? So these two things, so the 30-degree and the 4, are across from each other. I mean opposite, sorry. And so if we want to use opposite and we want to find the side x is adjacent to the 30 degrees. And so this is the problem set up. Let me just sort of stop here and see if there are questions. Right? We want to use the 30-degree, we want to use the 4, we want to find the x. So we want to use the opposite side and the adjacent side to 30 degrees. And opposite and adjacent is tangent. So this tells us, okay, we want to use tangent because tangent of theta is opposite over adjacent. And those are the two things we want to use. So that's the key, that's sort of the key setup that is oftentimes the most challenging part for people, is just figuring out what the heck is going on and what trig function am I going to use. The questions so far?
One question. So 30 is our theta?
30 is the theta, right.
So does this only happen in 30, 60, 90 triangles, or is it like all triangles that you can use it with?
So you can use it with any right triangle, so it needs to have a right angle. And there are right angled triangles that have angles other than 30, 60, 90, or 45 for that matter. But those are the angles that we know on the unit circle, right? So the angles that we're familiar with on the unit circle are 30, 45, 60, 90. And so it works for other angles, but since we're trying to do this by hand without using a calculator, it's going to be 30, 60, 90, or 45s.
Okay, thank you.
So we haven't finished this one yet, but there are other thoughts about this before we keep going? This is sort of the setup to the problem. This is everything I've written down so far is just trying to help us realize we want to use tangent to find x. And so what we know then is, like was just said, theta is 30 degrees, right? And so we know that tangent of 30 degrees equals opposite over adjacent. And opposite is 4, and adjacent is x. And so this is a way that we can relate the thing we want with things we know. Tangent of 30 equals 4 over x, right? We can solve for x in this equation, and we know how to find tangent of 30 degrees. And so that's sort of the main setup right here. I'm going to slide this down and finish this one off. I'm going to slide over to the side here and do tangent of 30 degrees, right? So when we do tangent of 30 degrees, and, you know, we haven't really done much of this at all together in class, which is kind of concerning to me, because I know this is the stuff that people get tripped up on, and I haven't been able to sort of check up on these things with quizzes. And so let me know if this makes sense. So the way you do tangent of 30 degrees is you go to 30 degrees on the unit circle, which is pi over 6. You write down the x and the y value. And so that's square root of 3 over 2, 1/2. And then tangent, you divide the y and the x. And so we would divide 1/2 by root 3 over 2. Flip and multiply the bottom. The 2's cancel, and so you get 1 over root 3. And so tangent of 30 degrees is 1 over root 3. And so you can replace tangent of 30 degrees with 1 over root 3. And now the only thing that's not a number in this equation is x. And so you can solve for x. All right, so that's the whole point here. I will finish off solving for x as soon as I can find my other pen here. And so the way you solve these fraction equations is you cross multiply. And so you do 1 times x and 4 times square root of 3. So that is the side length of x, 4 times root 3. And just leave it like that, right? This is a homework problem or a test question or something. Don't try to get a decimal answer. Just leave it as 4 times square root of 3. It's a great answer. It's got all the decimal places with it, like that. Thoughts?
Yeah, I got one.
Yep.
In page 60 where you have the special triangle, the special angle ratio, how
Yeah.
come it, in the tangent part of 30 degrees is root 3 over 3 and not tan of 30 is and is not 1 over root 3?
Yeah, good question. So that's what's called rationalizing the denominator, which is something I intentionally choose to skip talking about, but you might remember it from high school. So if you have 1 over square root of 3, you can take that and multiply it by root 3 over root 3, because this just equals 1, right? Because it's something divided by itself. But the two denominators multiply together and cancel the square root, so it becomes this, right? And then the top becomes this. And so what you get is square root of 3 over 3. And so you can see 1 over root 3 is actually the same thing as square root of 3 over 3. Sometimes people prefer to not have square roots in the denominator. And so that's why they do what's called rationalizing to get rid of that. My personal opinion is that that is a completely pointless thing to do and has no mathematical value. Just my opinion. I think it's a kind of thing that people do in high school because it's like kind of a cool trick and you're trying to like teach about square roots and squaring and like doing stuff like that. But like these two things literally mean the exact same thing. And so I don't really find a value in doing that. And so I usually just skip over that when we talk about these things. But since you pointed it out, that's why under tangent, it's got that value instead of 1 over root 3, because they really try to avoid square roots in the denominator. Notice how there's no square roots in any of these denominators because of that.
Yeah.
So so it really doesn't matter to me. You're welcome to do either one. Web work will take either one. Sometimes it's nice to know that they're equivalent. I think maybe that's one value in doing that. Like if you got this as an answer and then your friend got this as an answer, you might think that you got different answers, right? And it's nice to know that they're actually the same thing. So that's like some value in it, but I don't really fuss over that in particular, that sort of minor thing. But I hope that answers the question.
Yeah, it did. Thank you.
Other thoughts about wherever that one went? The one I just did. And so let me just sort of finish it. You're still welcome to ask a question, but let me just finish it and say, well, if we wanted to find h then, first of all, we could use Pythagorean theorem because we just found that x is 4 times root 3. And so we could use Pythagorean theorem and do a squared plus b squared equals c squared. But let's just pretend that we didn't find x and we wanted to use the 30 degree, the 4, and the h. And so for the 30 degrees, we would want to use opposite and hypotenuse then. So let me write that down. So if we wanted to find h, we want to use the 30 degrees. We want to use 4, which is still opposite 30 degrees, and the hypotenuse. Well, opposite and hypotenuse is sine. So we would do sine of 30 degrees is opposite over hypotenuse, which would be 4 over h. And we could solve this problem the exact same kind of way, right? Sine is the y value at 30 degrees. And we just found that the y value was 1/2. And so this would become 1/2 equals 4 over h.
Move the screen down, Professor.
And then you could just solve for h. Cross multiply, and you'd get h equals 8. You can see that, I hope. Let me know if you can. And so these are really great problems. You know, these like SOHCAHTOA problems are, it's kind of a, not really a culminating thing, but it's sort of is a culminating thing in trig, right? You're like using lots of the things we know about. You need to know the unit circle. You need to know box number 1, its applications. This is really how people find the height of big things. So if you haven't watched the video, what I say in the video is the thing on the next page is like things people really do. Like when people go out and find really big trees like redwoods and they want to measure how big they are, they almost never climb the tree and measure it. They like stand far away from it, they measure the angle up to it, and they measure their distance from the tree, and then they use SOHCAHTOA in some way to figure out what the height is. And so this is like a real kind of thing that people do all the time. I talk about in the video too how it's a nice way to figure out how big, how much rope you need to hang a flag, for example, right? This could be like a flag post, and you might want to know how much rope you need to hang something there, just for example. So there's really tons of these kind of applications where SOHCAHTOA comes in all the time. You use SOHCAHTOA like crazy in like a physics class, because physics classes are always representing the world as right angles, basically, and like doing stuff to figure out forces on them. So anyway, what I'm trying to say is this is one of those applications that usually carries over into other classes. Like if there's a reason you're taking Precalc for some other prereq in your major, it's probably, there's a good chance it involves SOHCAHTOA. So it's something you want to understand is what I'm trying to say. Okay, can I answer some other questions about this one in particular before we move on to other questions?
Page 61, and I watch videos, I'll like pause it and try to figure out the problem before you start it to see if I'm understanding what you said prior.
Mm-hmm.
61, the question with the tree, I got like lost compared to the problem you just explained to the one on 61.
So what were you thinking? Let me throw 61 in. So on this problem, we wanted to find the height of the tree, and we knew the base, right? And we knew this angle. And so we wanted to use 30 degrees. We wanted to use the adjacent side to 30. And then we wanted to find the opposite side to 30. And so that's what I wrote at the top here, right? We want to use 30 degrees, the opposite side, and the adjacent side. And so that's what led me to tangent, because we wanted to use opposite and adjacent. What were you thinking about when you saw it?
I just got lost because there's a lot of information on this video. So I was trying to like backtrack what you taught us before we got to this page.
Okay. Sure. So I'm sorry, you cut off.
Right after I watched what you said on the video, it made sense, but I got kind of like stumbled because there's a lot of information.
It is a lot of information. You know, we move pretty quick from like that first page where it's like, oh, SOHCAHTOA, this easy, fun thing. Like this thing is not that bad, right? And then all of a sudden we have to like put it all together in kind of a complicated way. But let me just sort of say what I said one more time in case anyone's still confused. We're given this picture. Maybe I'll just do it on the back too, so you can see it from like a fresh mindset. The picture looked like this. We had the tree right here, right? This is the tree. And we knew this bottom thing, I think, was 43 feet, and this was 30 degrees. And so you want this side, because we wanted to know the height of the tree. And so what you do is you think, what do I have? You have the 30-degree side, the 30-degree angle, and you have the 43 feet, which is adjacent to 30 degrees. Right? You're trying to relate it to the thing you know. And so right off the bat, we're like, okay, we need to use something with adjacent in it. And then what you want to find is the height, which is opposite 30. Which is the opposite of the opposite side of 30. And so that's, once you have two of those things written down, opposite and adjacent, we think about, well, what has opposite and adjacent in it? You think, go back to SOHCAHTOA, not this one, this is opposite hypotenuse. This one doesn't even have opposite. Oh, it's this one. This one has opposite and adjacent. And so that's what led me to, okay, use tangent. Right? This is the same thought process as what we just did in the last page. It just now has an application to it. And so that's why we say, okay, well, tangent of 30 degrees is very similar to the one we just did, actually, because it was also tangent of 30 degrees is opposite, which is the height, over adjacent, which is the thing we know. Anyway, and then it's very similar on the last page. But just sort of going through the thought process from scratch there. And I don't think Cameron necessarily did this, but I know it can be tempting maybe to like just go right to the printed out notes and maybe try to make sense of the printed out notes. And maybe that works sometimes, but sometimes it's very challenging to sort of come right into something that's finished that looks like this maybe and understand exactly what's going on without hearing me walk through it in the video. So if you are just trying to jump right to the notes, anyone, and you're having a hard time with that, maybe go back to the video from that section and let me explain it a little more carefully. So anyway, just to kind of finish it, we were at this step. We know that tangent of 30 degrees is 1 over square root of 3 that we found out in the last page. And so we set up the equation, and then we solve for height by cross multiplying again. So we cross multiply, get the height by itself, and figure out how big that tree is. Okay. So I do appreciate you guys talking about these notes. I apologize for claiming that no one watched them. That was my fault at the beginning there. But nice to have a little more participation, but I know we're just getting the hang of this stuff. So is there anything else I can help with this morning? Happy to keep talking here. Okay, if not, I'm going to go ahead and scan the things that I wrote down today on their own sheets of paper. I've been doing that the last couple sessions. I've been scanning them and posting them on the Blackboard. And I'll just remind you once again that I've been videotaping this. I've been recording this session. And so I will post that to YouTube, on the YouTube page. And I'm around. I'm available. And don't forget the tutors are available too, you know, Tuesday, Wednesday, Thursday nights at the Google Meet link I posted on Blackboard. So please keep that in mind. And I'll hang around if anyone has any other questions. But otherwise, thank you very much. Have a great day.